This is lesson 9.5, Symmetry. Your objectives are to identify line and rotational symmetries in two-dimensional figures and to identify plane and axis symmetries in three-dimensional figures. In a two-dimensional figure, there is line symmetry if the figure can be cut in half. There is rotational symmetry if the figure can rotate around and still line up against its old self. In a three-dimensional figure, there is plane symmetry if it can be sliced in half, and there is axis symmetry if it can rotate around and still line up perfectly on top of itself. So, to start, we will state whether the figure has line symmetry, write yes or no, and if so, draw all of the lines of symmetry and state their number. Number 1, does this have line symmetry? Well, imagine a line that would cut this perfectly in half, and there is one. It is right there, and that's the only one that will cut this perfectly in half. So yes, there is line symmetry. We have drawn it, and there is one. Number 2, does this have symmetry? Well, imagine a line that would cut this in half. There's one there. And there's one there. So yes, there is line symmetry. We have drawn them, and there are two lines of symmetry. Number 3, does this have line symmetry? And the answer is no. There is no line that you can draw that would cut that in half. State whether the figure has rotational symmetry. Write yes or no. If so, locate the center of symmetry and state the order and magnitude of symmetry. Number 4, to determine rotational symmetry, imagine this figure rotating around. When it rotates around, does it ever overlap itself? And the answer is yes. As this is rotating, this side here, when it moves around, will line up with this side here. And the top will line up with the bottom. So yes, this does have rotational symmetry. The center of the symmetry is the center of this figure. The order is how many times the figure maps onto itself in one full circle. Well, the side starts here. It travels 180 degrees to map onto itself, and then another 180 degrees, and it's right back where you started. So this maps onto itself 2 times in a full circle. So the order is 2. Magnitude is always 360 degrees divided by the order, because the magnitude is asking how many degrees the figure needs to turn before it maps over itself again. And for this, it's 180 degrees. Number 5, does this have rotational symmetry? Yes, this certainly can rotate and map onto itself. So yes, there is rotational symmetry. The center of symmetry is right there at the center of the shape. The order is the number of times it maps onto itself If you take this side, it goes 1, 2, 3, 4, 5 times in a full circle. So the order is 5. The magnitude is the number of times, or the number of degrees it takes to map onto itself, and that is found by 360 divided by the order, and that'll be 72 degrees. The order is how many times in a circle that a figure maps onto itself, and the magnitude is how many degrees to turn in order to map onto itself. Does this have rotational symmetry? Yes, it does. The center would be the center of the circular object. The order is how many times it maps onto itself in a full circle. If you start at the top, 1, 2, 3, 4, 5, 6, 7, 8, all the way around, 16 is the number of times it maps onto itself. So the order is 16. The magnitude is 360 divided by the order, which is 22.5 degrees. In other words, to travel from this place to this place, this will rotate 22.5 degrees. It will rotate 22.5 degrees, and that is between each gap. A paddle wheel on a steamboat is driven by a steam engine that rotates the paddles attached to the wheel to propel the boat through the water. If a paddle wheel consists of 18 evenly spaced paddles, identify the order and magnitude of its rotational symmetry. Well, you can imagine this wheel with 18 paddles going all around. Pretend that there's 18 of those. As this wheel is turning, this wheel will map onto itself every time one of the paddles lines up with where the previous one was. So one there, one there, one there, all the way around 18 times. So the order is 18. The magnitude is how many degrees you turn this between each mapping, and that is found by 360 divided by the order. The order is 18, and that's 20 degrees. So the order is 18 and the magnitude is 20 degrees. Remember each time that the magnitude is 360 divided by the order.